Today we're going to go over dividing radicals, which I'm sure you've probably have seen before. The real name of dividing radicals is called rationalizing a denominator, because what we have to do is, if we look at this problem, 5 over the square root of 2 is a number in a calculator. If we do 5 divided by the square root of 2, it's approximately 3.5. But what you have to remember in mathematics, it is improper to leave a radical in the denominator. And so what we kind of bring back is the idea of, if you recall, if you remember, the square root of 2 times the square root of 2 is always going to give us a perfect square, and the perfect square is going to give us the value of 2. If I do this for everything, square root of 3, next one, I'm going to get a perfect square, 9, and that answer is going to come out to be 3. And the square root of 4 is going to give me 16, and that's going to give me 4. So we're going to use that concept and that idea to come up with, how can I get the square root of 2 off the bottom? Well, I know if I multiply it by itself, it's going to give me a perfect square. And 2 times 2 is going to be the square root of 4, and that's going to give me a 2. When I do this, I try not to put the radical back in the denominator, because I know I'm trying to get rid of a radical. So whatever you do to the bottom of a fraction, you must do to the top, and so the top is 5 root 2. The only thing you have to check is that, can this radical be broken down? If it's being multiplied by another radical, there's a chance it may have to be able to get broken down. So we're going to look at another easy one. It has one thing you always want to check is, can you simplify? For example, if you had the square root of 15 over the square root of 5, before starting to rationalize the denominator and get rid of the 5, you're going to take 15 divided by 5, and that answer is the square root of 3. So as long as ever you can simplify, you want to do that first. So here, the square root of 2, I can't, so I get rid of it. Remember, when I do this, I'm trying to get the radical or radicand out of the denominator. So the square root of 4, and then that is 2. Whatever I do to the bottom, I do to the top. They're both in a radicand, therefore it is the square root of 6. I'm going to look at this one. It's kind of silly to start. First of all, there's a 2 in front and a 2 in front. So the first thing I'm going to do is take those right out. I don't want those involved. So now I have the square root of 8 and the square root of 10, and I see I have a radical in the denominator. That's not allowed. But I also see that 8 and 10 are even. So before I even start, I'm going to take square root of 4 and the square root of 5. I'm going to simplify this down by 2. And then I'm even going to look further to see that the square root of 4 is 2, and now I have 2 over the square root of 5. That is a simplified answer. The only problem with this answer is, now that I have a square root, the square root can't stay in the bottom, so I multiply top and bottom. This is going to give me 25 when I multiply, and the square root of 25 is 5, and the top's going to be 2 root 5. Now, had you started this problem by 8 over 10 and just simply multiplied, you would have got 10 on the bottom. You would have got 80 on top. Therefore, you need to take 80, 10, 8, 5, 2, 2, 4, 2, 2. You would have got 2 pairs of 2, so you would have got 4 root 5 on the top over 10, and then realize that 2 over that simplifies. So you absolutely could have done that. Might be easier for some. There's just a little more breaking down of a bigger number. Right, now we're going to come to a new concept. We haven't really probably ever rationalized the denominator of a higher index or a higher root. So the only thing is this, it's exactly the same concept, but if we're dealing with cubes, if I only multiply this by 2, that's going to give me the cube root of 100. And when I do that, that's 10, 10, 5, 2, 5, 2. That does not. If we have an index of 3, then if we went to a third value, this would give us the square root of 1,000, which then we could do 100 and 10 and 10 and 10, and we know that that would give us a set of 3. Now, you could also attempt to multiply it by anything that will give you a cube. So for example, like cube root of 4, I could do 4, 4, and 4, and I would have to get the cube root of 16 times 4 is 64, and that answer would be 4. But I could also do 4 times the cube root of 2, and that's going to get me the cube root of 8, and the cube root of 8 is 2. It doesn't have to be that number. It just has to be a cube root that comes out of that value. Now, to me, the easiest way without having to think about it is just to multiply it by itself 2 times. But you don't have to do that. You could come up with a smaller number that we know are cube roots. If you have to have a list of cube roots in front of you, or fourth roots or whatever, it wouldn't be bad to have a list like 2 times 2 times 2 is 8. 3 times 3 is 27, 64. You can make a ongoing list and attempt to get these numbers, and then that should help make it smaller. So what we're going to do is I'm going to multiply this by the cube root of 10 and the cube root of 10 if you want to write it like that, or you could have done the cube root of 100. And so 1, 2, and 3 is going to get me a 10. So when I do it up here, you have to do it by both as well. So then my answer is 10 times 10 times 5, 500. Now, of course, we have to check, can you take the cube root of 500? And that's 5, 100, 10, 10, 5, 2, 5, 2. You're going to see that we get 3 5s. So it's 5, the cube root of, and what's left is what? A 2 and a 2. So 2 times 2 is 4 over 10. And that's the cube root of 4 over and 5 over 10 simplifies. So it does simplify down once you get a large number like 500. Little trickier, but same exact concept, that multiplying any denominator by itself in a square root gets rid of it. Multiplying it by a cube root gets rid of it this way. Last thing we have to do with division of radicals, different than kind of Algebra 1 or Prop Stat, is that now we have a group in the denominator, and I call it a group because it's separated by a plus or minus, so this is a binomial. We have a binomial in the denominator. In order to get rid of this, I can't simply just multiply this by root 3 because it's a group, which would mean that would give me 2 root 3 plus 3 times 3, which is 9. That would become 3. But what would I do with this? So the only way to get rid of a group is to multiply this group by another group, and we're going to call it the exact same group, but instead of whatever the sign is in the middle, we're going to change it to its opposite. And this is what we call a conjugate. Okay? And a conjugate is literally the exact same group, but we change the value in the middle. Now, the reason we change the value is because when I FOIL, I'm going to get 4. I'm going to get a minus 2 root 3, but inside here I will get plus 2 root 3. And that is what we want because this and this will go away. And the last part of my FOIL will be plus minus minus square root of 3 times square root of 3 is 9. These will cancel, and I'll get 4 minus 3, and that is 1. So the bottom, or the denominator of my fraction, is 1. So what we have to remember when we do this, we're going to use a conjugate. The only way to get rid of a group is by multiplying by another group. And we want to change the sign so the middles will cancel. But what you have to remember is whatever you do to the bottom, you must do to the top. So 4 times 2 is 8. 4 times this is 4 minus 3. Okay, and you can have it over 1 or not. It's not always going to come out to 1. You could get any number under there at all. Let's try one more. I see the denominator is a group because it has a plus or minus. If you look at number 10, the top is a group for sure, but the bottom is not. So if I want to get rid of, I'm kind of jumping around, but if I want to get rid of this, I don't have to worry about the 3 except it's a multiplier. But to get rid of this on the bottom, I can just multiply by 5, and this would become 25, and the square root of 25 is 5, but I have a 3. So the denominator would be 15. When I multiply the root 5 up here, yes, I'm going to have to FOIL. But down here is not a group. It's only a group if it is separated by a plus or minus. So to get rid of a group, I need a group. I use the exact same group. So if that's negative, this is negative, whatever. The only thing that changes is the middle. And that's what we call a conjugate. So here I'm going to FOIL first, negative, negative. Out here is going to be negative, negative, which is positive 2 root 3. Inside here is a negative and a positive, so it's minus 2 root 3. And then last is positive, negative, negative. Root 3 is 9. Cancel, and we should realize that the square root of 9 is 3. Of course, it's very similar. 4 minus 3 is 1. It does not always come out to 1, believe me. It just happens to be. So negative 3 minus root 3 goes on the top. Negative, positive, negative 4, and value times radical, negative 2 root 3. Okay. All right, hopefully you can try some. I might supply another video on using a conjugate. You'll have some practice on IXL and Delta Math, but please go back to your PDFD, radicals PDFD. So that this was the notes we were doing, and now I'd like you to try some practice here, trying some of the groups on the bottom. Thank you.